to the virtual field trip over the San Andreas Fault to the Antelope Valley. Our first stop is at Vasquez Rocks Natural Area in Santa Clarita, California, to investigate the lithosphere at an elevation of 2,500 feet. At this stop, we can see the feature of uplifted and tilted sedimentary beds. The two processes that created Vasquez rocks are plate tectonics and differential erosion. Plate tectonics has slowly compressed, folded, and uplifted this rock formation to about 45 degrees. Differential erosion of the rocks has created uneven layers. Our next stop is at a wind farm in Mojave, California, to investigate the atmosphere at 3,035 feet in elevation. The turbines are here because of the strong gusty wind characteristic of the area. Gusty southwest winds blow over Palmdale and Mojave almost every afternoon and evening. Also known as Chinook winds, they're caused by a rapid downslope movement of relatively warm air. It's caused by a pressure gradient of high on the windward side of the San Gabriel Mountains and low on the leeward side. We now move to Saddleback Butte State Park in the Mojave Desert to investigate the hydrosphere at 2,622 feet elevation. We are in the western Mojave Desert, overlooking an alluvial plain. Vast blankets of decomposed granite, sand, and silt surround us. It is a high desert landscape. At this stop, we will observe the natural feature of pack rat middens, which gives data about past rainfall at Saddleback Butte State Park. Here is an image of a pack rat midden. The middens look a lot like really large birds' nests filled with twigs, plant debris, and seeds. The desert wood rat collects objects and plant material from their foraging area and makes them a part of their middens. Over time, the rat urine preserves and crystallizes the plant material, which can be removed and analyzed to reconstruct the past climate over the past 10,000 years. These middens reveal information about this area, that 10,000 years ago, large lakes covered large portions of the Antelope Valley. This process of dramatic climate change at the end of the last ice age dried up the lakes, forcing the plants to adapt to the change in precipitation. Our last stop is at Mormon Rocks, near the Cajon Pass, where we will explore the biosphere at 3,322 feet elevation. Mormon rocks are oddly tilted sedimentary rock, officially known as Rock Candy Mountains. These rocks are riddled with holes, now dwellings for lizards, owls, and pack rats. Here is an image of those holes in Mormon rocks. The hole features are significant to the biosphere because the geology of the rocks provides shelter for the biota of the area. There's a human element to the process of how these holes were created. Natives of the area ground up acorns with a mortar and pestle. This process left behind many mortar holes that can be found in the rocks throughout the region. This stop concludes our virtual field trip over the San Andreas Fault to the Antelope Valley. I hope you enjoyed learning about the lithosphere, the biosphere, the hydrosphere, and the atmosphere.